Bismillahirrahmanirrahim. Assalamu alaikum. Okay, now let's discuss angle of elevation and angle of depression. When we talk about these two angles, basically these two angles are an application of trigonometric ratios. Okay, so when we are applying these two angles or any of these two angles, basically we'll be applying trigonometric ratios to solve the problems related to these two angles. Okay, so to understand these two angles, the first thing is to understand how we are going to conceptualize these two angles. So if I am looking straight, like I'm looking like this, so this is straight, I'm looking, this is at the same height of my eyes, so this is my line of sight. Okay, if this is something at some height, this is above my line of sight, so this, when I'm looking at this thing, it is making some angle with my line of sight. Or if it is below the line of sight, if I'm looking at it, it is also making an angle with reference to the line of sight. So let's understand this. Okay. Okay, if this is someone who is looking at something and this is the object. Okay, so this is line of sight, right? And if the object is above the line of sight, so, and it looking at this, since this is above the line of sight, so this is making an angle with the line of sight, and this angle is called angle of elevation. And if something is below the line of sight, looking downwards, so it is also, okay, something is here, right? So it is also making an angle with line of sight, and this angle is called angle of depression. Okay, so if we have some idea of these two angles now, so let's take an example. Suppose this is some building and this is 43 meter high. Okay, and there is someone who is looking towards the top of the building. Okay, right, and this is ground level. Since from here it is looking towards the top of the building, so it is making an angle, and this is because it is above the line of the sight, it is angle of elevation, and supposedly here it is 34 degrees. Okay, and if the base of the building is point A and somebody who is looking towards the top of the building is at point B, and we have to find the distance between point A and B, which is supposedly x meters. So how are we going to do that? We're going to apply trigonometric ratio. What is this? Straight building. It is making 90-degree angle with the ground. Okay, so this thing is our perpendicular, and this ground level is base, right? So when we are comparing perpendicular and the base, these two ratios give us tangent, right? So perpendicular over base, is equal to tangent. And what are we going to do? This is 43, this is x, this is tangent 34, and so it will be x is equal to 43 divided by tangent 34, and it is approximately 63.75 meters. Okay, pretty simple thing. Using angle of elevation, now we know the distance between the 2 points, right? Now let's take angle of depression. Okay, suppose we have a cliff, and this cliff is 65 meters high, and here we have a boat. Somebody is on the top of the cliff and looking towards the boat. Okay? The line of sight here is this thing. This was the line of sight. So it is making an angle over here. Supposedly, if it is, angle is 32 degrees. Okay. And if we have to find, this is the base of the cliff, and we have to find how far the boat is from the base of the cliff, right? So this is x meters. Now, how are we going to find this? Of course, we are going to apply a trigonometric ratio, but this is, okay, assume this, let's make it a straight, let's make it, okay. So just to give it an idea that it's a 90-degree angle. So the cliff is making with the ground level 90-degree angle. So we have a 90-degree angle over here. We have a perpendicular, we have a base, but we need this angle. What is this angle, right? Now, if we remember, when we have two straight lines, straight and parallel lines, and there is a transversal, then the alternate angles, this is equal to this, and this angle is equal to this angle. The alternate angles are equal. The same is the case here. This is straight line, line of sight, straight line, baseline at the ground level, straight line. So these two are straight lines, parallel lines, and this is a transversal between them. This angle is going to be the same as this angle, so this is also 32 degrees. Now, perpendicular over base equals tangent 32 degree. So 65 divided by tangent 32 degree is equal to x, which is x is equal to, rather approximately equal to 104 meters. Okay, so again, basically very simple things. Now let's take one more example to understand the elevation and the depression angles. Okay. Okay, I've taken this example from the book. Okay, now this thing here is a building. Let's say this is point B and this is point C. This point C, B to C, it is a building, and the height of the building is h meters. And on the top of the building there is a flagpole which is 12.2 meters high. And there is someone at the point A, And if that someone is looking at the top of the building, which is point C, it is making angle 26 till the top of the building, which is angle of elevation. And if that someone is looking towards the top of the flag pole, and this point, which we can say is the point D, from A to D, and that it's making an angle of 35 degree, right? Now, if we have to find how far this person is from the building, which is X meters, right? And so let's find out the distance, and we are going to apply trigonometric ratio as before. So perpendicular over base is equal to tangent, and first thing, let's see, first I am going to apply this thing just for the building. And if this someone is looking towards the top of the building, the height of the building is h, so the perpendicular will be h. Base is of course x, and the angle here is 26, so tangent 26. So, or I can write it like this, h is equal to x into tangent 26. Okay. Now I am going to consider if somebody is looking towards the top of the flagpole. So what will be the height, total height from the base of the building till the top of the flagpole? So it will be, the perpendicular will be 12.2 plus h over, and the base remains the same, x is equal to, now the angle is 35, tangent 35, so 12.2 plus h is equal to x, tangent 35, and I can write it like this, h is equal to x tangent 35 minus 12.2. Now if we see, I have this equation 1 and 2. In both the cases here, the height h is equal to x tangent 26 or x tangent 35 minus 12.2, right? So in both the cases I am equating for height h. So I can take this equals to this, because both left hand side of both the equation is same. So I can say it's like this, x is equal to, x tangent 26 is equal to x tangent 35 minus 12.2. Now what is tangent 26, which is 0.49, x is equal to 35 is 70, so 0.70 x minus 12.2, right? Now from here, coming here, so it will be 0.49x minus 0.70x is equal to 12.2. So it is 0.21x is equal to minus 12.2. So it is cancelled out. And we have here x is equal to 12.2 over 0.21, which is 58.1 meters. So this is still not the height of the building, it's just the x. So how to get the height of the building here? I'm going to apply the x value here. So it will be 58.1, which is x, into tangent 26, which is 0.49. So I have here 28.5 meters. So the height of the building is this. Okay, so again, pretty simple things. Just we have to keep in mind what trigonometric ratio we are going to apply, and we have to check either it is angle of elevation or depression. Thank you.